Today, let's discuss about a topic. How to reduce the carbon emission, but simultaneously increase food supplies in poor countries. We have two purposes today. First, increasing food supplies. Second, reducing carbon emission. First, let's talk about the problems in those poor countries. In these poor countries, the problem of inadequate food supplies has never come to an end. Their prime goal is to increase food production instead of reducing carbon emission. However, speaking from a larger scale, the global greenhouse effect has been worsened these days due to the tremendous amount of carbon emitted from almost every human activity. We must seek a solution that can simultaneously solve these two tricky questions. Moving on to problems, we have three problems that are discussed today. First one, carbon dioxide emission. Second, soil compaction. Third, wasted water. It's no exaggeration to say that most of the machines, such as tiller, cultivator, and hydro exhausters, as you can see on the PowerPoint, are all powered by either gasoline or diesel fuel. As we all know, that burning those fossil fuels contributes a lot to carbon emission. It's obvious that the approach of applying machinery doesn't help. Moving to our second problem, which is soil compaction. What leads to soil compaction? Heavy load from machines decrease the porosity of the soil and eventually will lead to the decline of the crop's production. Also, with the raise of density, the soil becomes impermeable. As the soil isn't likely for infiltration to take place, subsurface runoffs will increase, which severely exacerbates soil erosion. Along with the frequent use of fertilizer, which is a common myth among farmers when encountering such problems of production decline, the land will eventually become infertile. Meanwhile, irrigation plays an indispensable and significant role in agricultural field. How is that? First, to the current system, the water that pumped up isn't effectively used, but just randomly and also excessively sometimes sprayed on the whole field. In those water, nearly 50% vaporize directly back into air. Another 20% becomes subsurface runoffs. Still another 15% turns into groundwater. That is, only 15% is absorbed by plants, which is highly inefficient. And as we know, that the water resource is relatively precious in those poor countries. Therefore, this problem shows the wasted water that happens in our current system of irrigation. So, as we have seen those problems that's discussed, let's move on to our solutions. First, we have solutions to the problem of carbon dioxide emission. Hoping to solve this problem, we would likely to introduce a traditional machine that was widely utilized by farmers in early Taiwan. Simply speaking, the reason we use the machine is merely because it won't emit any carbon dioxide. Simply speaking, the machine consists of two gears, a track of chain, and several pedals attached to the chain. Also, stretching out from one of the gear's axis, another set of pedals was installed as the power resource. When it's driven by human force exerted on the outstretched pedal set, the gear will drive the track up. Along with the help of those pedals, we're now able to pump water up without emitting any carbon dioxide. And here we have a video to demonstrate how our prototype works.
Okay, we are Team I, and this is our model for our Keel water wheel. As you can see here, we have two cylinders over here. The both of these is powering the entire mechanism, and the cups on the conveyor belt stop is meant to collect water from point A into our boxes. Box over here is designed for easy cleaning. So let me demonstrate. All you have to do is take out the pipe, pull out the sides, and now you can clean the inside very easily. And it's also very easy to assemble. All you have to do is put it back and plug the pipe back in. Here I have these two white balls that are representing the water that we're getting from point A into our boxes. Here I'm going to put one ball on the conveyor belt, representing the water that we have already got from the source and going up the slope. And here the other ball is going to represent the water that we're getting directly from our water source. And now please turn the machine. Yes. As you can see, the ball goes all the way up from the slope into our collection box. And the water these balls representing is going to go through this pipe into our drip irrigation system. The whole point of this Keel water wheel is to power our drip irrigation system without using any fossil fuel consuming machinery. Here we have the pedals that are meant for pedaling by humans. This is how we are going to avoid using fossil fuel consuming machinery.
Alright, now move on to the second solution. Here we're solving the problems of soil compaction and wasted water. By solving these problems, we introduced the concept of drip irrigation. Usually, drip irrigation was designed in the purpose of reducing water usage. It's why we adopt it since our project is expected to work in poor countries and less expense can soothe their economic pressure. However, there are still two potential problems that existed in the drip irrigation system. The two potential problems, number one, emitter clogging. Generally, we have emitters installed between two dividing pipes that can make water drip. However, moss or bacteria in the pipes will clog the emitter. This leads to the frequent replacement on the emitter in drip irrigation. And since one of our goals is to reduce the total cost, we can't let this happen. Second potential problems is randomly dripping. Though we may say that drip irrigation helps reduce water usage comparing to other systems, it sometimes doesn't have a specific spot for water to drip. This causes water to randomly drip on the surface of the soil and then becomes subsurface runoffs, which will then lead to excessively wasted water. Solving these problems, we have to combine these problems with the previously mentioned technique, which is our Keel water wheel. Using the Keel water wheel, we are able to drag water, but that's far from enough. After being dragged up, the water is then stored in a special designed tank, in which two lids are designed to be removable in the purpose of more convenient cleaning. Attached to the tank, water pipes are used to diverge the stream to different fields. During the process of diverging, we use the potential energy the water has stored when dragged into the tank to help run the whole process. With a slight slope, stream can naturally flow down through the pipes. Considering the problem of emitter clogging, we discard the original design of emitter and decide to drill a hole directly on the pipes. Besides avoiding the clogging problem, we can also solve the randomly dripping problem. By calculating the distance between each plant, we drill the holes right beside the plants. In addition, we make an additional process of digging a shallow pit around the root to let water flow in. This makes irrigation becomes more efficient than it was before. In addition, we make an additional process of digging a shallow pit around the root to let water flow in. As I've mentioned before, that soil compaction will lead to the decline of food production. We can relatively increase food production by solving the problem of soil compaction. All these make irrigation more efficient than it was before. By doing all the process we've mentioned, we can not only reduce the carbon emission, but also increase food production. With enough resources and time, we believe that our method will improve the complete problem of how to reduce carbon emission, but simultaneously increase the food supplies in poor countries. Thank you for your listening.